This video is on the objective understand and compare confidence intervals in context. And this is number 1. This is the first video on a question from your Newton Alta homework related to this objective. So again, if you're unfamiliar with the material, the title of the concept, the objective, what it means, try clicking on more instruction and read what they have to offer, watch videos, take notes, look at their examples, and maybe that'll help you in working out problems like this. Now this is one of those interactive problems where I have to move some dots around. So let's read through this. So the amount of sleep an adult gets each night has a normal distribution with a population standard deviation of 1.8 hours and an unknown population mean, right? So sigma is known, 1.8, the population standard deviation, but mu is unknown, right? The population mean, the average number of amount of sleep all adults get. So if a random sample of 44 adults is taken and results in a sample mean of 7.2 hours, find a 95% confidence interval for the population mean. And I say use the tool below. I am going to show you, I'm going to draw a picture before I do this. Right? It's going to involve the central limit theorem. Right? So remember, we have this population. And suppose suppose x is the random variable that represents the amount of sleep an adult gets. And they're telling us that x, right, the amount of sleep an adult gets each night, is normally distributed with an unknown mean, the mean mu, and a standard deviation sigma, right, where mu is unknown, because this whole section, this whole homework here has been on creating confidence intervals. And a confidence interval is what we use to guess what a population mean or a population proportion is. Mu unknown, and the standard deviation was given to us. They said suppose we know that the standard deviation sigma is 1.8. Now, from this population, a sample is taken. They said a sample of size, n equals 44 is taken. So now suppose we look at groups of size 44, and remember, by the central limit theorem, right, CLT, by the central limit theorem for means, if I look at all possible samples of size 44 and look at all the mean numbers of the mean hours of sleep those groups of 44 get, all those means, all those x bars, right, all those sample means for groups of size 44 would be approximately normally distributed with a mean of mu sub x bar, the mean of the means, and a standard deviation sigma sub x bar, where the mean of the means, remember, is the mean of the population, but that's unknown. Right? So instead we use a point estimate. Right? We use our point estimate, the mean of the sample. Right? Now the mean of the sample, they told us, was 7.2 hours of sleep. It was the average for the sample of size 44 that we took. So we're going to use 7.2 here as our initial guess as to what mu is. Now again, we don't know mu, but we're using our point estimate here as an initial guess. And the standard deviation of these sample means, remember the sigma x bar, was the standard deviation of the population divided by the square root of the sample size. And we know both these things, right? The standard deviation of the population, we were told, was 1.8 hours divided by the square root of the sample size, right? The square root of 44. Which I'll punch this in the calculator and round this to several decimal places. let's pull up the calculator here. We got 1.8 divided by the square root of 44. So our standard deviation for these sample means is approximately 0.27136. And I should be able to draw a picture then of the distribution of these sample means, right? These means for, groups of size 44 adults. So let's say this number line represents possible values of the sample means, right? Possible values of, again, the means sleep times for groups of size 44. It says normally distributed, so I'm going to create this, symmetrical bell-shaped curve over this, and underneath the peak is our point estimate, right? Our 7.2, because again, we don't know mean, the actual mean mu. We have our point estimate, 7.2. And then under these inflection points here, which again should be the same distance on either side, it's symmetrical. This is one standard deviation away. So 7.2 plus, let's say about 0.3. So this is approximately 7.5. This is approximately 6.9 hours of sleep. And we do 2 standard deviations, 3 standard deviations, and so on. But here's a picture of the distribution, the density function, the density curve for the distribution of the sample means, for groups of size 44 adults. Now we're asked to create a 95% confidence interval. Now remember, 95% confidence, remember that empirical rule. Within 2 standard deviations of the mean, you had approximately 95% of the area. So if I'm creating a 95% confidence interval for mu, right, we're trying to guess, with a reasonable amount of confidence, right? This 95% is called our confidence level. We're trying to guess with a reasonable amount of confidence, 95% confidence, what mu is, what the population mean is, what the average amount of sleep all adults get, not just groups of 44. But we can use our groups of 44 here to make our guesses. Now remember, there's a lower bound and an upper bound. The lower bound is our point estimate, which is x bar, minus, 2 standard deviations, right? We're doing 95%. So the lower bound of this, the lower value in this interval, is minus 2 standard deviations, right? Minus 2 of those sigma x bars. And then the upper bound will be our point estimate, the middle, plus 2 standard deviations. All right, and this 2 standard deviations, right? This 2 standard deviations here and here, that's what's called our margin of error, right? ME, margin of error. All right, well let's just let's calculate these. All right, so I'm just going to pull my calculator back up. Now we had our point estimate was 7.2, right? So I'm just going to do actually, you know what? I'm going to do this. I'm going to take my previous result, right? This was that standard deviation, 1.8 divided by the square root of 44. I'm going to store this as the letter x. So now whenever I use the letter x, it's that number. So it makes it a little more accurate. So we have our lower bound here is 7.2 minus twice the standard deviation, minus 2 times this x. So if I take 7.2 and subtract 2 standard deviations, and they say ask us to round to 2 decimal places, this is approximately 6.66. If I round that to 2 decimal places, what's on that number on the calculator. And then I'll take the same entry and just change the minus to a plus. Take 7.2 plus two of those standard deviations to get the upper bound, it's about 7.74. So here's our what they call our 95% confidence interval estimate for mu. So what we're saying here is that based on this sample, right, based on this one sample of 44 adults, I am 95% confident that the average amount of sleep that all adults get, right, the entire population, the mu, is between 6.66 and 7.74 hours, somewhere in here. And if I wanted to go 99.7%, then I'd do within 3 standard deviations. Yeah. Okay, now let's see. Let's go to the website and play around with these. Now they told it. Now you gotta move the dots around, right? See, this is for X bar, 7.2. Right there. That was our sample mean, our point estimate. This is sigma, not sigma X bar, but sigma. All right, this is the population standard deviation, which they told us was 1.8. And then this N was the sample sizes, right? They said they took 44 adults. So I move this to 44. And then what was the confidence level? 95%, right? They wanted us to create a 95% confidence interval. And you see the picture they drew here? It's kind of like the picture I drew on paper. Let me pull it up side by side here. See that picture? With 7.2 in the middle and 2 standard deviations below, 2 standard deviations above. Let me get rid of the paper though. And look, 6 point. Now this is a little more accurate because technically 2 standard deviations below and 2 standard deviations above isn't exactly 95% under the curve. It's more like 1.96 standard deviations below and 1.96 standard deviations above, but we'll see that in a later section. So we got from 6.67 to 7.73, right, which is close to what I had. Close to what I had when I just did 2 standard deviations below and above. So using use these numbers here as the lower bound and upper bound of my 95% confidence interval, and they said again round to 2 decimal places. So lower bound 6.67 when this number here is rounded to 2 decimal places, and the upper bound 7.73 when that's rounded to 2 decimal places. Submit, and good. And they say great work, that's correct, and all that. Again, read your answer explanations. Even if you're right, so read the answer explanations, and especially if you're wrong, right? Read through the answer explanations, try to figure out where you went wrong. All right, so hopefully this showed you how to do this kind of thing here, what these markers mean and what you got to move them to, and what you're entering. Look at these red numbers here, what you're entering in your confidence intervals, and just pay attention. Again, pay attention to how many decimal places they want you to round your final answers to. So hopefully that helps with your attempt at these, and thanks for watching.